Okay, let's do some chemistry.
Yes, let's do that.
Okay, so last time we worked on this photoelectron spectroscopy graph, right?
Mm-hmm.
And I like it, of course, because it's data that students at all sorts of different levels can understand and deal with. And we also, as a result of that, had a series of patterns that we identified in the data. Things like there being 2 electrons in this lowest location, and then 2 and then 6 in this next band, and then 2 and 6 in this third band. So that's we're going to go from there on to some things that I think are a little bit useful. And one of the things I want to highlight right now is one of the reasons that we think that I think that we use this diagram to get to a different diagram to understand where electrons are, but I want to highlight the reason why that's easier than what I perceive as being the alternative. So we're gonna do something that is difficult, messy, and somehow I do, you do, all of our students have to somehow keep all of these dirty, messy things in our heads because it's too difficult to keep track of them that way. But I'm going to lead you through that in just a second. Okay?
I think you're doing the dirty work by showing them how messy it is. So
Well,
that
maybe.
way they don't have to deal with it themselves.
Yeah, maybe. Okay, so I'm going to start by showing some images that are in the textbook. So let me share my screen here again. Okay, so in the textbook, it shows pictures of the locations where electrons are found. And it's the first location it's called the 1s, and it looks like a little sphere, and it's a small location in the very center of the atom. And then there are there's one that's a little bigger called the 2s that's also a sphere. And then there are these, near the 2s are these ones that are called the 2p. And they are like circles or lobes, but they don't actually touch the center part of the nucleus. So we're going to work with drawing some of these orbitals and some of these locations where the electrons are. And I'm going to try to help you understand some of the things that we might have to deal with, okay? And so we know, based on the photoelectron spectroscopy data, that there can be a couple of electrons down in this lowest level. And so I'm going to draw an X, Y, and Z axis. Okay. And the center of any particular atom is right down here in the middle of the nucleus, okay? And we know from some mathematics that's described in the textbook, we know that the first place where we can find electrons is in this first location called the 1s. And you'll see that I'm trying to draw a sphere that represents the 1s, okay? And then we know that there's this next location, which is a little bigger, and I'm trying to draw a sphere. And sometimes the electron is all on the outside here. So there's a second location, okay? So I've drawn what's known as the 1s, and then I drew around it what's known as the 2s, okay? How am I doing so far?
Looking all right.
Okay, thank you. I appreciate the compliment. Okay, so, and all of these are centered on this nucleus. And so I'm going to draw the next orbital, which I think I've been doing blue, so I'm going to switch to black. And the next orbital is one of the 2p's. And so I'm going to draw a lobe on one side of the axis and one on the other side of the axis. And I had something like that. And so if this is the x coordinate, then this one that I've just drawn would be the 2px. Okay?
It's on the x-axis.
Yeah, yeah. And so let's do the y coordinates. And so I'm going to draw another one on the y-axis. Is my hand in the way, or is it not too bad?
It's not too bad.
Okay. So I'm going to draw this what's known as a p orbital. On the y-axis, and so I've got a 2py, and then coming in and out of the plane, that's why I drew this one a little fatter, so it kind of comes towards you, and a skinny one that disappears into the back. There's also an orbital. Let's see what I can do for that one. Let's I think I've got a pencil here. Okay. Well, maybe I'll do this one in black as well. So coming out around this way, this is extending towards you and extending into the plane behind the piece of paper. Is the 2pz. Okay? So we've got all of those things, all of those orbitals, and that accounts for this location, which is the 1s, this location, the bottom location here, which is the 2s, and then those 2p orbitals are these where these 6 electrons are found. Okay, so I'm going to keep on going. So now I've got this another set of orbitals up here, and I'll make those maybe with. We'll go back to blue for those. So this is the 3s orbital, and it's a sphere, and it's a little further away from the nucleus, and something like that. So that would be the 3s orbital. And what we saw when we were looking at the photoelectron spectroscopy data, so here's 3s, and then I've got another 6 electrons, and that's another 3p orbitals. And so we've done 1s, 2s, and now we're looking at, we did the 2px, the 2py, and the 2pz, and we've done the 3s, and we're going to have some 3p's that go along with those as well. And they're the same, they look the same as the 2p's, but they're a little bigger and a little further away. So I've done 3s, so now I'm going to do 3p's. Oh, that might be a little big. Hopefully, so that's the 3s, the 3px, the 3py, and the 3pz. Okay?
Oof.
Okay.
Okay.
So, I think I'm an amazing artist. However, I think that's a mess. I think it truly represents the height of my abilities, and it's hard to see what's going on. And here's the critical point for you, Kevin. So I'm going to take my blue marker, and I'm going to put an electron in one of those orbitals. There's my E for my electron. Okay. What orbital is that one sitting in, Kevin?
I don't think it's in the 1, but it's hard to tell if it's in 2s, right? 2p, 3s. I can't tell at all.
Yeah, I know. I mean, it is just a mess, right? And so one of the hard things for beginning chemistry students, maybe for all chemistry students, maybe for all chemists, is somehow you have to take this data translate it into some sort of three-dimensional understanding and begin to figure out where those electrons are. And in this three-dimensional, well, this is actually a two-dimensional view, right? I'm pretending that I'm drawing it as a three-dimensional view, but atoms are three-dimensional, right? And so going from going from data to a pseudo three-dimensional view to trying to understand where those electrons are, this is a very, very hard, in my opinion, atomic structure diagram. And so being able to, so what we've developed other tools to try to help us understand where those electrons are. And those electrons and those tools, once we have those, you still have to, in your head, in my head, we have to try to somehow relate it back to this messy view or build some concept in our heads. So if I share the screen again, let me show you one more time. So if I share the screen, in this view, the orbitals are all nicely separated, but we know that in any particular atom, all of the centers of each one of these three coordinate axes are all superimposed on one another, just like I have in my diagram. And so that's the putting all of these things together. You have to do in your head, I have to do in my head, our students have to do it in their heads. And I don't think that's a trivial task. It's maybe easy to memorize some things, but it's quite hard to get some real conceptual understanding that you can use. So let me show you how we try to solve that problem a little bit. So I started over on this corner I started by drawing the orbitals, the locations where the electrons are, and I started naming them here on the side. And so what we're going to do is we're going to do a flat diagram that represents the locations of these orbitals. And so we're going to draw a line to represent this 1s orbital. We're going to draw a line to represent this 2s orbital. We're going to draw 3 lines to represent 2p, 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 x, y, z. We're going to draw a line to represent the 3s orbital and 3 lines to represent 3p, 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 x, y, and z. So in the textbook, in almost all chemistry textbooks, and lots of chemistry discussions, you'll see a diagram that looks exactly like this. And that's trying to say, here's a simple diagram where if I write back here, I had this electron. If I write this electron right there on this diagram, I say to you, Kevin, what orbital, what location is that electron in? And you say
1s.
1s, and you say it without any doubt, right? Whereas in my diagram over here, it was hard to say where it was, right? And if I put, for some reason, I have an electron right here, I say, what orbital is that in? And you say
2p, and I think that's x.
Yeah, it's 2px, yeah. And so that is a way of this what's called an energy level diagram. That energy level diagram allows us to say, hey, we're talking about an electron that's in the 1s, or an electron that's in the 2s, or an electron that's in the 2px, or the 2py, or whatever. And we will use this diagram a lot, but you, me, I, everybody needs to be able to say, think about it. Yes, we're talking about these orbitals with these shapes in these locations. And that's one of the hardest parts, I think, because you've got to somehow make some sort of mental manipulation to keep track of those things.
Yeah, that is definitely just a lot more visually appealing than your masterpiece.
Yeah, thank you. Yeah. And what I want to show you is I just want to go back to screen share for a second. Share this one. Okay, so here is the orbitals as they're shown, right? And if I go to the very next slide from the textbook, you'll see there down in this corner, there's that energy level diagram. 1s at the bottom, 2s, 2p, 3s, 3p, and so on. And so I reiterate, you have to get used to seeing these energy level diagrams, thinking about where the electrons are, and then somehow relating it back to some sort of three-dimensional structure of which orbitals and what the shape of those orbitals are and where those electrons are. Not trivial, but possible. And finally, if we think about it this way, if I go back to the ionization energy, the photoelectron spectroscopy chart, it was all there for us all along. We looked at these trends. Well, here's the 1s, here's the 2s, then the 2p, then the 3s, then the 3p, and then up here is the 4s, which we haven't talked about, but it's all there. So it all comes from the same place. It all comes from the same data, the same types of experiments, but it's different views and different ways of understanding the same thing.
Yep.